Hi everybody, I'm James Cross with SDS Automation, and we're here today to do a demonstration video of the ChannelBender SXP. The SXP model is our top of the line channel letter machine. It's also our most popular, and this machine will do things that no other channel letter bender in the market is capable of doing. It will really help to reduce labor costs by automating processes that are currently being done manually at most sign shops. So this is a smaller version of the letter we're going to run. It's just a fairly simple letter A, and we'll run the outside part and also the inside part of the letter. And we're going to be using a brushed aluminum finish, 040 material. It's 3.5 inches deep. So after the flange is put on, the total letter depth is 3 inches. And a couple of things to pay attention to as the machine is processing and forming this letter. On the back side, you'll see the machine creates the flange. It's a 1/2 inch deep flange. And then it will also notch the inside and outside corners in order to create that nice sharp bend. And here in the overlap, where the seam of the letter joins together, you're going to see there are 2 1/8 inch pilot holes or rivet holes on each side of that overlap. And there is also an offset break. If you look very closely, you can see that this side of the overlap, where my finger is on your left, actually sits down underneath the other side, so it really creates a nice flush even seam straight across there. And that helps also to line up those rivet holes. You can see, hopefully you can see some daylight through there depending on the angle, but once those holes are punched in there, you can just put in a rivet and pull it tight, and the seam of the letter is closed. On the bottom side of the letter, you can see here, this side we put 1 1/4 inch drain hole, and this side we put 2. This is simply demonstrating that the hole punch mechanism is height adjustable, and it's electronically adjusted within the software. So it can do a single hole in one position, or it can do multiple holes in different positions. And those holes can be punched anywhere in the wall of the letter or in the flange. So if you wanted to rivet backs onto the flange, you could actually have your CNC router drill the rivet holes, and our software is intelligent enough that it can read the location of those holes and put a corresponding rivet hole in the flange. And lastly, you will see the machine, when it starts the letter, it will snip out the flange on one side of the overlap. And right now your fabricators are doing that most likely with tin snips. So, you know, the drilling of the rivet holes, the drilling of the drain holes, the removal of the flange, all things you're doing manually right now. This machine automates it and just really helps to bring those labor costs down. So when the letter's done, we'll be able to tell you exactly how long it took. And for the operation of the machine, I'm here with Kyle, our technical operations manager. He's going to come in and explain a few features in the software, how we set up we open up the file, we set the tool path, etc. So at this point, I'm going to turn it over to Kyle, and then you'll have a chance to see exactly what this machine can do.
All right, we're going to get into the software here, take a look at setting up a file and getting the machine running with the pieces that we're looking for. So this is our SDS Bender CAD software. It's proprietary to our machines. It's developed in-house. Gives us the ability to open CAD files of different file types. Most commonly is a DXF file, which is what I have here. So let's take a look at this. I've got numerous elements in this file, but we're going to focus on this letter A here. A few other things about our software. We've got our material selector or material catalog, where I can get in and look at all the materials that have been set up for my machine and select the one that's appropriate for the job I'm doing, as well as the material I have loaded in the machine. In this case, We have our 040 3.5 inch. So we'll select that. That will automatically apply software settings as well as machine settings to process this material properly. So let's get into our letter A. This is the same CAD file that was used at our router. So with that in mind, we need to create the return a little bit bigger than that back so our back panel will fit into that return. So when I draw my toolpath, an offset will automatically be applied according to the direction that I draw my toolpath. So in this case, for the outside of the letter, I'm going to draw my toolpath counterclockwise, and that's going to apply a positive offset so that our back panel will fit down in there. Now once we're done drawing our toolpath, we have some options for that. We can adjust the quantity. Say I'm making 5 sets of this sign and I need 5 of these. I can adjust my quantity here. I can apply different types of seams. In this case, we're going to use our overlap seam, and that will then also apply rivet holes to that. Maybe if I were doing 063, I could designate more of a butt joint. I do have some other options here that we really aren't needed on this particular piece, so I'm going to go ahead and click Apply and Confirm. And let's go ahead and draw another toolpath on the inside of this A. And in this case, we're going to draw that toolpath clockwise so that the offset is applied on the correct side. And again, we'll go with these settings. Now I'm going to set up some drain holes on this letter A. We have our punch selector here. Well, we've already preset some different heights where we want drain holes, and as James showed you, we're going to do it 2 different ways. On this first leg, I'm going to apply 2 drain holes. So we'll select this one and we'll select this point right here, and we've got that one set. On this other leg, we're just going to do 1 drain hole, just so we can show you the versatility here, how this is all controlled in our software. There's no manual adjustments on the machine for that at all. So let's select this one, place it here. So now that I have a couple toolpaths drawn, I can easily see them on the screen here. Or if I had a file or I had a number of toolpaths drawn, I could see all those together in our toolpath list view. And by clicking toolpath list view here, we can see some toolpaths. I did have some others drawn already, but we're going to focus on this A in the A insert here. So I can check both of those. It will then show me how much material is needed for those 2 pieces, so I can just kind of take a quick glance at my coil of material here, make sure I've got enough for that. But then I can click run. As soon as I click run here, the machine's going to start processing both of these pieces consecutively. First the outside and then the inside. So let's go ahead and run this, and then we'll kind of go through some of the functions that are happening here. So we start each piece with a fresh cut at the beginning. This helps us get a nice clean cut at the start for that overlap seam. We also saw it notch out that bottom portion there, and that's for that so our flange does not overlap. So here in the main cabinet, we've got our feed unit moving the material, our punching unit, punching holes where we designated. Again, this is moving up and down automatically, as we can see here. And then we've got our flanging unit behind here creating the flange, and then our notching unit notching the flange where called for on those outside corners or for a radius. Bending our offset overlap there. You can see that first set of drain holes coming through. right, so we got our first piece off there. That was a runtime, which I can see in our software, of 1 minute and 44 seconds. And now it's going to continue with the second piece, the insert there. All right, so we've got our two pieces here. We've got our outside here. As you can see, while that piece was running, I slipped a couple rivets in there, and those shows how well those holes line up and how easily that can be done. We've got our drain holes on the bottom here. We've got like we set up in our tool path, one on this side. Excuse me, it was this way. It was two on this side and one over here at different heights. And then for our insert here, we can see how that gave us a nice, gave us our overlap, offset overlap there. And this is a smaller piece, so it's a little bit trickier to work with, but see how that comes together as well. So there you have it. That second piece, this piece had a runtime of 1 minute and 7 seconds. So we had about 3 minutes, a little bit less than 3 minutes total for both pieces there. And that was the SXP running 040 with flange, featuring our punching unit here.